This is the Pre-Calculus Chapter 8 test review. For a field goal attempt, a football is kicked with a velocity shown in the diagram. Draw a diagram that shows the resolution of this force into its rectangular components. So if we draw the rectangular components, part of this force is going to go in the x direction, part of it is going to go in the y direction. The football is going to travel along this vector at 90 feet per second at an angle of 30 degrees. So this would be your resolution in rectangular components. Now, if we actually find the magnitude, you find the component form using the magnitude and the direction. To find the x component, you are going to do the magnitude of your vector times the cosine of the angle. And to find the y, you're going to do the magnitude of the vector times the sine of the angle. So in our case, we are going to do 90 times the cosine of 30 degrees, which tells us our x component is going to be 77.94 feet per second. And the y component is going to be 90 times the sine of 30 degrees, which means my y component will be 45 feet per second. Find the component form of vector AB. Now remember, to find component form, you're going to do x2 minus x1 and y2 minus y1. So we're going to do 6 minus negative 3 and negative 2 minus 5. So our component form of vector AB will be 9 and negative 7. To find the magnitude of vector AB, you're going to do the square root of the x squared plus the y squared. So we're going to do 9 squared plus negative 7 squared, or 81 plus 49. So the magnitude of vector AB will be radical 130. To find the direction of angle AB, we're going to use the tangent, which is y over x. So the tangent of our angle, from our component form, the y value is negative 7, the x component is 9. To get the angle by itself, or to get the theta by itself, or to take the tangent to the other side, you're going to use the inverse. So it'll be negative 7 over 9, or theta is approximately 37.9 degrees. Now we're going to do some vector operations. So 2 times vector w plus 3 times vector z. The first thing we're going to do is we're going to take this and we're going to distribute into the vector. So I'm going to have negative 8 with 2, and then we're going to have negative 9 with 0. Next, you're going to take it, because it says addition, we're going to add the pieces that are in the same location. So this will be negative 8 plus negative 9 and 2 plus 0. So this will give us negative 17 and 2 for our sum. For the next one, we're just going to do negative 5 times vector y. Again, we're just going to take that negative 5 and we're going to distribute it to both of the pieces. So this will give us negative 10 and negative 25. We need to find the unit vector. To find the unit vector, you are going to do 1 over, so our unit vector is 1 over the magnitude of your vector times the vector itself. So let's find the magnitude of vector w first. So this is going to be 3 squared plus negative 4 squared, or 9 plus 16, which gives us radical 25, or the magnitude of vector w will just be 5. To find our unit vector, We will then do 1 over that 5 times vector W itself. So we're going to take this 1/5 and we're going to distribute it to both pieces. So our unit vector will be 3 over 5 and negative 4 over 5. Remember, the unit vector is a vector that's going to have the same angle as the original vector, but this vector will only have a length or a magnitude of 1. Find the magnitude, find the component form given the magnitude and the direction. Now this is the same thing as finding the x and the y as we did on that first example. Remember, you're going to do the magnitude times the cosine of the angle and the magnitude times the sine of the angle. So we're going to do 10 times the cosine of 150 degrees and 10 times the sine of 150 degrees. And this is going to tell us that vector v will have the components of negative 8.66 and 5. A quarterback is running forward at 4 meters per second. So he's running forwards, that'd be a positive 4. He's not running up into the air any, so the y component will be a 0. And he's going to throw a football with a velocity of 26 meters per second at an angle of 38 degrees. So we need to find the component form of the football. So when we find the component form, we're going to see that the football has a vector of 20.5 and 16. So we need to find the resultant vector. To find the resultant, you're just going to take the player and add it to the football. So our resultant vector, if we do 4 plus the 20.5, it's going to give us 24.5, and 0 plus 16 will give us 16. But now we need to find the resultant speed and the direction. Now speed, in this case, is the same thing as the magnitude of our vector. And remember, to find the magnitude, you're just going to take the component form and you're going to square each piece and add them together. So we're going to do 24.5 squared plus 16 squared. And if you put that into your calculator, we're going to see that the ball is traveling at a speed of 29.26 meters per second. Next, you need to find the direction. And remember, to do this, you're going to do the tangent of theta is equal to y over x. So from our component form, we know our y value is 16, our x value is 24.5. To get the angle by itself, you're going to do the tangent inverse, or we're going to have our direction is going to be equal to 33.1 degrees with the horizontal. Find the dot product of u and v. Then determine if u and v are orthogonal. So to do the dot product of u and v, so if this is x1, y1, x2, and y2, we're going to do x1 times x2 plus y1 times y2. So we're going to do 2 times negative 14 plus 7 times 4, or negative 28 plus 28, which tells me u dot v is equal to 0. Next, you need to determine if it's orthogonal. Remember, the two vectors are going to be orthogonal if they equal 0. So if it doesn't equal 0 on your test, make sure you write not orthogonal, so I know you're answering that question. But if it does equal 0, you will tell me it is orthogonal. Use the dot product to find the magnitude. So if we use the dot product, we're going to do A dot A. So just like on that last problem, to do the dot product, you're going to multiply the first pieces together and then add it to the second pieces added together. Or in this case, A dot A is equal to 58. Now to find the magnitude of the vector, we can just take the square root of A dot A. So this will just be A dot A was 58, so we can just write this as radical 58. Find the angle between the two vectors to the nearest tenth of degree. So to find the angle between two vectors, this is not just the angle of one vector, this is the angle between the two, so this one is different. You are going to do the cosine of theta is equal to u dot v over the magnitude of u dot times the magnitude of v. So let's find u dot v first. Remember, it's first piece times the first piece plus the second piece times the second piece. So we're going to get that u dot v is equal to 26. Next, we need to find the magnitude of vector u. So it's going to be negative 1 squared plus 5 squared, or radical 26. And the magnitude of v is going to be 4 squared plus 6 squared, or 16 plus 36, which will give us radical 52. So with that information, we're going to find the angle between them. So we're going to do u dot v, which is 26, over the magnitude of u times the magnitude of v. Remember, to get the theta by itself, to move just the cosine, we are going to do the inverse. And we're going to get the angle between these two vectors is 45 degrees. Next, we need to find the projection of u onto v. To find the projection of u onto v, you are going to do u dot v over the magnitude of v squared times vector v itself. So we already know from previous that u dot v is 26. The magnitude of v is radical 52, but when we square it, that radical will disappear, so we're just left with 52. And then we're going to multiply it by vector v itself. Now, if we reduce that, 26 over 52 is just 1/2. So we know that our projection of u onto v, if we distribute this 1/2, we will get our projection is 2 and 3, or we can also call that our W1. Because for the next part, we need to write u as the sum of the two orthogonal vectors. Now we know that vector u is negative 1 and 5. And we know vector W1 is 2 and 3. So we need to find vector W2. To do this, we are going to subtract vector W1 to the other side. So W2 is going to equal negative 1 minus 2. We're going to subtract those first components, and that's going to give me negative 3. And then we're going to have 5 minus 3, which is going to give me 2. So if we write u as the sum of W1 and W2, W1 we know is 2 and 3. And we know W2 is negative 3 and 2. Sophia is pushing a shopping cart with a force of 120 newtons at a downward angle of 52 degrees. So first we need to find the force as a component vector, the component form of the vector. Remember, it's going to be magnitude times the cosine of the angle. Now, since she's pushing down, this is going to be a negative 52 degrees, and it's going to be 125 times the sine of negative 52 degrees. So the force vector in this case will be 73.88 and negative 94.56. And she wants to see how much work is equal to force dot AB. She wants to see how much work in joules Sophia would do if she pushed the shopping cart 200 meters. Now, if you're pushing it forward, that's your x component, you're not pushing it up or down any. So she wants to move it 200 meters forward, but not anywhere up or down. So to find the work, you are going to do your force vector dot your AB vector. Remember, when you do the dot product, it's going to be 73.88 times the first component on the second plus the second component for the force times the second component for AB. And if you do that multiplication, you're going to get 14,776